this video we're going to look at 2018 question 10 part C. It's based on stoichiometry, and in this question really we're using one formula the whole way down along, just rearranging it. So that formula is one that we've seen from very early on in our course, and that is that moles are equal to mass over relative mass. Okay, so we're just using that formula the whole way down along, rearranging it. Something a little bit different maybe in the last part, but we'll deal with that when we come to it. So if you take a second to read the question, alright, and then we have how many moles of iron were removed from the object in the rust treatment process. So there you're looking for the amount of iron basically in your product. So over here, how much iron have you got in your products, because that's been removed from the object in the rust treatment process. Okay, so our formula again is moles equal to mass over relative mass. This iron phosphate, the relative mass of the iron phosphate is 151. The mass that we have is the mass given in the question of 4.53 grams. So our moles is going to be equal to 4.53 over 151, and that gives you the answer of 0.03 moles of iron phosphate. So that's 0.03 moles of iron. Okay, and that's your answer to part 1. For part 2 then, what mass of rust was adhering to the object before the treatment? Okay, so that's finding the iron here in your iron oxide. So how much iron have you got on the reactant side? So you see here that the ratio between your reactants, your iron on the reactants, and your iron in the products, so that's a 1:2 ratio. Okay, so your ratio is okay, so this is your iron oxide over here, and this is your iron phosphate. Okay, so if we have 0.03 moles of iron phosphate, then to get your moles of iron oxide, you have to divide that by 2, because you have 2 moles of iron phosphate of every 1 mole of iron oxide. So you're going to have 0.015 moles of iron oxide. Now, in the question, you're asked for the mass. Okay, so if we take our usual formula that we have moles is equal to mass over relative mass. Okay, we have the number of moles and we can calculate the relative mass. So the relative mass of iron oxide is 160. So if we want to find the mass, okay, the mass is going to be equal to the moles multiplied by the relative mass. That's going to be 0.015 multiplied by 160. And that gives us 2.4 grams. And that is your answer to part 2. So now if we move on to part 3, what is the minimum volume in centimeters cubed of a 6 molar solution of phosphoric acid needed to remove all of the rust? Okay, so your phosphoric acid, that is this 2H3PO4. So we want to find the minimum volume of that we need to remove all of the rust. We know the concentration of it. Alright, so we want to find the minimum volume required. So from the question, we have to find the minimum volume. We have the concentration, and also from our balanced chemical equation, we can work out the number of moles of the phosphoric acid we have. Okay, so if we have, and there's a 1:2 ratio between the iron oxide and the phosphoric acid, we have 0.015 moles of your iron oxide, so that means we have 0.03 moles of the phosphoric acid. So our concentration is equal to 6 molar, and our number of moles is 0.03. Okay, we want to find our volume, the minimum volume that we needed. Okay, so this figure here, this 6 molar, that's 6 moles per litre. Okay, to get this to, right, we asked in the question for centimetres cubed, so to get this to a centimetre cubed figure, we're going to, now to get it to a moles per centimetre cubed, right, we've 1000 centimetres cubed here, so to get it from moles per litre to moles per centimetre cubed, we are going to divide by 1000. So if we do that, if we have 6 over 1000, we're going to come out with 0.006. Alright, and that's moles per centimetre cubed. Now, so the other number that we know in this question is the number of moles we have. We know that if we have a concentration and we multiply it by the volume, that will give us the number of moles. So we have our concentration in centimetres cubed, so we have 0.006, and we know that our final answer is 0.03 moles. So this volume here, that is the minimum volume that we're looking for. So that means it's just a little bit of rearranging. So our volume, so our volume is going to be equal to 0.03 over 0.006, and that is going to give us 5 centimetres cubed of the phosphoric acid. And the last part of our question then is, what volume of liquid water, density 1 gram per centimetre cubed, was produced in the reaction? Okay, so we're looking for the amount of water. Okay, volume of water. Now, just from the balanced chemical equation, alright, there is a 1:3 ratio between, we'll just go with the simplest one, the iron oxide, and the water. So if we have 0.015 moles of your iron oxide, we're going to have 0.045 moles of your water. Okay, so moles of H2 equal to 0.045. Our relative mass of water is 18. Okay, so if we have moles and multiplied by the relative mass, that gives us mass. Okay, which is not what we're being asked for. We're being asked for volume. So if we use what they give us in the question they tell us that the density is 1 gram per centimeter cubed. In this case, you'll see it doesn't really make a difference, but perhaps in other questions it might. If we multiply by our density, that will give us our answer in litres, or in volume, sorry, not in litres, but will give us the volume. And because our density is grams per centimetre cubed, it'll give us our volume in centimetres cubed. Okay, so it's going to be moles, which is 0.045, multiplied by our relative mass, which is 18, multiplied by our density, which is 1. Okay, and that gives us a final answer of 0.81 centimetres cubed. And that is our answer for part 4 and the final part of that question.